You're listening to Stardrift FM. It's late, the stars are out, and you've tuned in just in time. This is your weekly space bulletin. 7 stories from the edge of discovery. Grab your coffee, settle in, and let's drift through what happened this week in the cosmos. Let's start with something that should make every astronomer a little embarrassed and a lot excited. 2 ESA researchers, David Orion and Pablo Gomez, built a neural network called Anomalies. They pointed it at the Hubble Space Telescope's archive, 35 years of images, nearly 100 million cutouts, and told it, "Find me the weird stuff." 2.5 days. That's all it took. The AI flagged over 1,300 true anomalies. More than 800 of them had never been documented in any scientific paper. Ever. We're talking 86 new gravitational lenses, places where space-time itself bends light into rings and arcs. 18 so-called jellyfish galaxies trailing long tentacles of gas. Over 400 galaxy mergers caught in the act, and several dozen objects that simply defied classification. Think about that for a second. These things were sitting in the data all along, hiding in plain sight for decades. It took an AI 2.5 days to find what thousands of astronomers had overlooked. And here's the kicker. With telescopes like Roman, Euclid, and Rubin coming online, the data flood is only going to get bigger. Tools like Anomaly Match won't just be helpful, they'll be essential. Now for something most people never think about. When a satellite sends data back to Earth, where does it go? The answer is ground stations. Big dish antennas scattered around the planet. And right now, that infrastructure is a massive bottleneck. Enter Northwood Space, a startup out of El Segundo, California. This week, they announced $100 million in Series B funding, plus a $50 million contract with the U.S. Space Force. Their product is called Portal. It's a flat, phased array antenna, 9 by 5 feet, that replaces multiple traditional dish antennas. One site can be installed in 12 hours and start talking to satellites the next day. They're planning 82 beams across 18 global sites by the end of this year, and they can produce over a dozen of these arrays per month. The space economy isn't just about rockets and satellites, it's about the plumbing, the ground infrastructure that actually makes everything work. And Northwood just raised a very big bet that they can fix it. Switching gears to geopolitics, and this one is spicy. At the European Space Conference in Brussels, France's Minister for Space, Philippe Baptiste, made a very blunt statement. He called for a Buy European Act, a policy that would stop the EU from purchasing non-European components for defense and space. His exact words, "Our main ally has become highly unpredictable." He was referring to the United States. Baptiste pointed out that Europe used SpaceX to launch its own Galileo navigation satellites, the very system designed to be independent from American GPS. He brought up Ukraine, where Starlink connectivity was cut during a counteroffensive. His message was clear. Europe needs its own satellite constellations, its own launch capability, and, to quote, "no American override switch." Germany's space minister echoed the urgency. "Time is of the essence," she said. And last year, Airbus, Thales, and Leonardo announced a $7 billion merger to compete with SpaceX. Whether you think this is smart strategy or political posturing, one thing is certain: the space industry is becoming a geopolitical arena. Fast. Late Tuesday night, a Falcon 9 lifted off from Cape Canaveral carrying GPS-3SV09, the 9th in a new generation of GPS satellites for the U.S. Space Force. But here's the detail that got me. This satellite is named Ellison Onizuka, after Colonel Ellison Onizuka, the Air Force test pilot and NASA astronaut who was lost aboard the Space Shuttle Challenger on January 28, 1986. Exactly 40 years ago today. The satellite itself is no joke. It carries encrypted M-code signals, anti-jamming technology for military users, 3 times more accurate than older GPS satellites, 8 times better at resisting signal interference. There's also an interesting backstory. This mission was originally assigned to ULA's Vulcan rocket, but got swapped to SpaceX's Falcon 9. SpaceX pulled off the fastest turnaround ever for a national security mission, just 41 days from integration to launch. GPS isn't just an app on your phone, it's strategic infrastructure. And this week, it got a little bit stronger. Alright, this one is for the propulsion nerds, and honestly, it might be the most important story on this list. NASA just announced they've completed a cold flow test campaign on the first flight-like nuclear reactor unit since the 1960s. The 60s? That's how long it's been. Over 100 tests were conducted at Marshall Space Flight Center between July and September last year. The test article, built by BWX Technologies, is a full-scale non-nuclear engineering unit about the size of a 100-gallon drum. What they were testing: how propellant flows through the reactor without actually going nuclear, checking for vibrations, pressure waves, the kind of stuff that can destroy an engine in space. The project manager called it the most detailed flow data for a flight-like space reactor in more than 50 years. Now, a reality check. The DRECO program, which was supposed to put a nuclear thermal rocket in orbit, got canceled last year due to budget cuts. But the engineering work continues, and every test like this brings nuclear propulsion closer to reality. If we ever want to send humans to Mars in months instead of years, this is the technology that gets us there. This next one is quietly revolutionary. A team, including Cornell researcher Jake Turner, just published a paper in Nature Astronomy describing a new way to detect signals from exoplanets using archival radio data that's been sitting around for years. Their method is called RIMS, Multiplexed Interferometric Radio Spectroscopy. They used it to analyze 1.4 years of data from LOFAR, the European Radio Telescope Array. From that data, they synthesized 200,000 dynamic spectra of stars and exoplanetary systems. And buried in the noise, they found something remarkable. Radio bursts from the GJ6A7 system, a nearby red dwarf with a Neptune-sized planet. This signal pattern is consistent with the planet disturbing the star's magnetic field, driving intense radio emission. If confirmed, this would be only the second direct detection of radio emission from an exoplanet ever. And it opens the door to something huge: mapping magnetic fields on alien worlds. Magnetic fields that might be essential for habitability. The technique works on archived data, which means there could be signals from dozens of exoplanets hiding in data we already have. We just didn't know how to listen. And finally, let's end with something that breaks the rules of physics, or at least bends them. Astronomers using data from the brand new Vera C. Rubin Observatory have found the fastest spinning large asteroid ever recorded. It's called 2025 MN45. It's 710 meters across, about half a mile. And it completes a full rotation every 1.88 minutes. Let that sink in. A rock the size of a skyscraper, spinning so fast it should fly apart from centrifugal force. But it doesn't. That means it can't be a rubble pile, the loose collection of rocks held together by gravity that most asteroids are. This thing has to be solid, monolithic rock. Probably a fragment blasted from the molten core of a much larger body billions of years ago. What makes this even cooler? Rubin Observatory found it during its commissioning phase. Just 7 nights of observations. This is the very first published science from the largest digital camera ever built. And if it's finding record breakers during testing, imagine what the full 10-year survey will uncover. That's your bulletin for this week. An AI that found what humans missed: the invisible plumbing of the space economy. Europe drawing a line in the cosmic sand. A hero's name in orbit. Nuclear engines reborn. Whispers from alien magnetic fields. And a rock that spins so fast it should be dust, but isn't. This is Stardrift FM. Thanks for tuning in. Stay curious, stay up late, and we'll see you next time at the edge of the universe.